In this video, I'd like to talk about the math question of the day for Thursday, April 20th, 2023. And with this example problem, we need to simplify this rational expression here. And to answer a question like this, you will need the skills of Algebra 2 or maybe even PreCalculus, depending where you might learn something like this. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, we can start working through it. And if you do have suggestions for future questions of the day, feel free to leave those as comments. Now, when simplifying a rational expression, one thing that we can attempt is to factor the numerator and denominator and see if we can cancel anything out. And let's start with the denominator. You might recognize that this is a difference of two squares. In fact, if we rewrite it as a squared minus 3 squared, it will be a lot clearer that we are subtracting two squared numbers, which is why we call this a difference of two squares. And in general, let's say we have m squared minus n squared. To factor an expression like this, we can factor this into the first one minus the second one, ignoring the squares now, multiplied by the first one plus the second one. And of course, you can check this by redistributing and showing that essentially the middle terms cancel out and you end up with this difference of two squares. So we can factor a squared minus 3 squared into the first one minus the second one, multiplied by the first one plus the second one, again ignoring those squares. And I encourage you, check this by remultiplying it back out. So we can factor this denominator, since it's this difference of two squares, and we can also recognize that the numerator is a sum of two cubes. So if we rewrite a cubed plus 27 as a to the third power plus 3 to the third power, it will be clear that this is a sum, we're adding, of two cubes. And we can factor a sum of two cubes. Now, the formula for this can often be a little bit difficult to remember, but there are a couple tricks to keep it in order. If, let's say, we have x to the third plus y to the third, then this will factor into x plus y multiplied by x squared minus x times y plus y squared. And there's also a difference of two cubes, which looks like x cubed minus y cubed, and this would factor into x minus y multiplied by x squared plus xy plus y squared. And you can confirm these for yourselves by redistributing, multiplying the x to all the terms, and then multiplying y to all the terms so that you get 6 terms, and many of the terms will cancel out so that you just end up with these two cubes added together. And likewise for the difference of two cubes. And one way to keep these formulas in order is that when you have a sum, the sign and the linear expression is the same. And likewise, when you have a difference, the sign in the linear expression is the same as well. So in the first expression, it's always the same sign, and then the next sign is the opposite, and the last sign is always positive. And you can see that's true for the difference. The first sign is the same, the second sign is the opposite, and the last sign is positive. But like I mentioned, these can be a little bit difficult to remember, and in many cases you will just have to memorize these. So let's apply our formula for a sum of two cubes. We have a cubed plus 3 cubed, so we can factor this to a plus 3, we're now ignoring the cubes, multiplied by a squared minus, we're now using the opposite sign, keep the sign the same for the first linear term, and then it's the opposite sign. We multiply the two together, ignoring the cubes, and then we square the second one. And as always, this last sign is a positive sign. And I encourage you, again, check this by redistributing. We'll do the same with the positive 3, and you can show that it is equivalent to a cubed plus 27, or a cubed plus 3 cubed. And at this point, we can set this original rational expression into its factored forms. So in the numerator, we have a plus 3 multiplied by a squared minus 3a plus 3 squared, or we can just write that as 9. And in our denominator, we had that difference of 2 squares, which we factored to a plus 3 multiplied by a minus 3, or we could switch the order if we want. But the important thing to notice here is that a plus 3 is in the numerator and denominator. So these will cancel out, since something divided by itself is always 1. And at this point, what we're left with, this a squared minus 3a plus 9, all divided by a minus 3. This is our fully simplified rational expression. Now, if you do want to check that this is actually correct, what you can do is plug in some a value. Let's say a is equal to 1. Let me use a different color here. We'll set a is equal to 1. We get 1 plus 27, which is 28. We get 1 minus 9, which would be negative 8. And we can divide top and bottom by 4 here, so that we get 7 over negative 2. Now let's plug in a is equal to 1 in our simplified expression and see if we get the same answer. We get 1 minus 3 plus 9. So we have negative 2 plus 9, which is 7, and 1 minus 3, which is negative 2. It's the exact same answer, so we can feel confident that this simplified expression is correct.